I'm realising that we're starting to run short of a little bit of time for your reports, and I'm just going to quickly run over these calculators that are available for us online. So this one is the SkySieve free beam calculator, and like I said, I'm only showing this at the moment because we're running a bit short of time on the report. There is a way to actually calculate these that you will need to know, but through our exam practice over the Christmas holidays, you'll be able to fill those knowledge breaks there. So firstly here, like in this calculator, it says add a beam. Just going to click there, and I know that the length of my bridge is 44 metres, and I'm just going to add it. Next, I want to add some supports. At one end, I want a pin, and I'm going to put this on the left because that's where all my drawings have been. And then my other support is going to be a roller, and I'm going to add it to the right. Okay? So you see here, nice drawings coming up everywhere. I'm now going to add my first universally distributed load. I'm going to start at the point 0, and in the case of my bridge design, I know that it goes for 8 metres. Also, the starting magnitude is 78.5 kilonewtons. That's based on the calculations we got from the bridge design program, and it continues universally distributed at 78.5 for the entire 8 metres. So I'm just going to add that there, and you can see that comes up. I now have a point load for the truck, and it is going directly down. The location of this point load I know is at 12 metres from the left. 12 metres, and I know that the load itself is at 554 kilonewtons. So I shall add that in as well. I also know that I've got another uniformly distributed load. In this case here, it starts at the 16 metre mark. It goes for the 44 metres, and it too is 78.5 kilonewtons. And I'll add that in. So you can see here, this is a great free body diagram of the bridge that we've got, and it's got all of our dimensions and everything in it. So here down the bottom you can see the first 8 metres universally distributed, then it's up to the 16 where we've got the point load, and then 44 metres. So here it's quick, it's as simple as pushing the solve button. Now this solve button, again, it's calculated out here our reactions. So our vertical reaction on the left and our vertical reaction on the right. As I'm coming down here, you can see it's produced the shear force diagram for us. Here, you can see that we've got this upward force going up. We're going directly up. Our universal load is bringing it back down, across to our point load, and then across to our universal load before going back to the 0. Here, with our bending moment diagram, we start at 0 and again we finish at 0. Starts here as an arc, straight line to the next point, and then it comes back into the arc to finish. And this is along the same lines as these diagrams here, as this diagram here. Like I said, I will go through and give you some examples of how we can actually calculate this and hand draw these in preparation for the HSC. But for your report, I thought it was a nice little tool that you could use directly now to fill in the information required for the shear force and the bending moment diagram.